Ladies and gentlemen, welcome to our geography video on the ecological footprint as a measure of population size and resource consumption by me, Henry McDonald, Owen Ray, Will Simmons, and Ryan Shorkey.
Ecological footprint is defined by the theoretical measurement of the amount of land and water a population requires to produce the resources it consumes and to absorb its waste under prevailing technology.
Some of the factors that impact an ecological footprint are as follows.
Arable land, land used for growing crops; pasture land, land used for raising animals for meat; and forest for getting supplies to build buildings and furniture.
Also, oceans impact your ecological footprint because of marine products, as well as infrastructure, which is like roads and factories, and also energy costs, which is the land used to absorb the carbon emissions.
This parking deck serves as an example for a large ecological footprint because a lot of resources are used in this area and it's a vast amount of space not being utilized for multiple functions. Here we have the Little Sugar Creek Greenway, which serves multiple functions in the city of Charlotte. It states that population size and resource consumption is a good measure of ecological footprint. However, our group thinks that population size and resource consumption is not a good measure of ecological footprint for the following reasons.
Now, what Ryan said makes logical sense because when you look at a country that's not very developed, like this slum area, they can have as many people as they want living there, but if there's no electricity, then their resource consumption is going to be low, therefore their ecological footprint is going to be low. However, compared to a situation like an urban setting where there's low density but a high ecological footprint.
Statistical evidence to back up what Henry was rambling about. We did a Spearman's rank of 6 countries with a high ecological footprint and 6 countries with a low ecological footprint and compared it to the population. And we found that the Spearman's rank was not statistically significant.
What you are looking at here are two maps distorted for population size on the top and ecological footprint on the bottom by country. As you can see, there is no correlation because most countries are not the same. Look specifically to the Americas and Africa.
Study, the Democratic Republic of Congo is an example of a country with a high population, 20th, and a low ecological footprint, 134th.
Population is a bad measure of ecological footprint, but a better measure is resource consumption, which takes into account the amount of inputs and outputs that a city uses, which directly relates to the ecological footprint.
Makes sense, because there's some cities that are very industrialized, so they obviously consume more and have a larger ecological footprint, while there's other cities that don't consume that much because they aren't developed, so their ecological footprint is low.
Spearman's rank, we compared resource consumption and ecological footprint.
We used the same 6 countries with a very high and very low ecological footprint and found the Spearman's rank to be 0.9441.
There's a strong correlation.
What you are looking at here are two maps distorted for water consumption on the top and ecological footprint on the bottom by country. As you can see, there is a positive correlation because most countries are the same size.
An example of a country that shows this relationship is Qatar. Qatar has high energy consumption, ranked 3rd among countries around the world, and a high ecological footprint, ranked 2nd among countries around the world, thus showing a direct correlation between the two.
In conclusion, what we are saying is that ecological footprints are not described well by both resource consumption and population size, because the population size is simply not a good measure of ecological footprints.
Yeah, and that makes sense because our case study Qatar showed that there was a strong positive correlation between resource consumption and ecological footprint, therefore showing that resource consumption is a better measure than population size.
Using Spearman's rank, we find there's no significant correlation between population size and ecological footprint. For example, the Democratic Republic of Congo had a large population and a low ecological footprint.
In conclusion, we found that the ecological footprint does not equal population size and resource consumption. It would be better if it was just ecological footprint equals resource consumption by itself.
A better way to be able to measure ecological footprint would be by development, because that is the cause behind small populations having a large ecological footprint. But that we can save for another geography video.